Hello and welcome. In this presentation we are going to look to apply logarithms to histograms. Now, suppose this data was the number of Twitter followers that different members of a particular family had, and we were asked to represent this on a histogram. Now, using my TI Inspire, I would end up with a plot that looks something like this, which is quite difficult to work with. You can see that most of the action, which basically is all of these except for the last, are in this first column, and the final entry here, which is the 23 million, is in the final column. And what we're going to do is try and make this scaling a little bit more usable so that we can possibly draw an interpretation from the data that's been provided. So currently this particular scale is what we would call linear. That is, it has equal spacing and we move up 1 unit at a time. What we're going to do is create what's called a non-linear scale. So you'll notice here I go from 1 to a 10 to 100 to 1,000 to 10,000. Each time I'm multiplying by a unit of 10. And you could think of 1 as being 10 to the power of 0, 10 is 10 to the power of 1, 100, 10 squared, 1,000, 10 to the power of 3, and so on and so forth. And this is what we're going to do to our axis. We're going to get it to look a little bit like this. And instead of writing the big numbers such as this on our axis, what we'll do is represent our axis as 0, 1, 2, 3, where this particular number here represents the index, or if you prefer, it represents the log. So that 1 represents that 1, that 2 represents that 2, that 3 represents that 3. And to remind us that we are using what's known as a log scale, we will name our variable with the word log to indicate that we are using the log scale. So it's the log of the Twitter followers. Just up here, you'll see here we were just using Twitter followers, but along here we are using the log of Twitter followers. So just moving on to the next slide here, what we actually do is we perform logs, a log operation of each one of those values that we had. So you'll see here we're performing a log of the 5, log of 23 million. So you'll notice back with our data, our first value was 5, and what we do is perform a log of each one of these individually all the way up to the 23 million. Now this is how you do each one. There's a couple of them done individually, but we'll do them all in one hit, and we're going to use our TI Inspire calculator to do that. So off to our calculator. This particular column here contains the Twitter followers, and this next page over here was what I actually had as a copy in the actual slide pack just a second ago. So what I'm going to do is create a new column here, and in here I'm going to put the log of my Twitter followers. So I just need to type this LOGTWITTERFOLL. I've got to be careful I don't make that too long, and I'm going to say I'm going to apply the formula, and the formula will be, for each one of these elements here, I want to perform the log. So you'll see here, control log. Looking down here, it has to be to the base 10, and instead of putting 5 or 18, I'm going to say use the name of this variable here, which is Twitter followers. So it'll take the element that's here and it'll apply it each time all the way along here. So find the variable will be Twitter followers, and apply. There you have it. And back to here, this is where I've got the linear scale, which is just the Twitter followers. I'm going to change this to be the log of my Twitter followers. So there you have it. The graph just makes a little bit more sense now. You can probably provide a little bit of interpretation there, just remembering this is the log scale now. So this here is 10 to the power of 1. So that's 10. So that's where 10 would be. That's where 100 would be. That's where 1,000 would be. 10,000. 10 million is there, etc. I'm just going to tuck this away for a little while, my calculator. And just move to the next slide. So I have generated this particular slide, and we can provide some interpretation to this if we wished, and we possibly would say that, you know, the log of Twitter followers is, you know, looks fairly symmetrical with one possible outlier at 23 million. Now, there's two specific operations that you'll need to be able to do when you're working with logs, specifically for histograms. The first one is to be able to find the log of a number. So for instance, find the log of 72. To do that, you would have noticed it's log to the base 10 of 72. And there is the value there. The other thing you need to be able to do is work in the reverse direction. So for instance, to find the number when the log is provided. So say that now I want to do find the number whose log is 3.6767, and the operation that I need to do this time is I will perform a 10 to the power of 3.6767, which would give me 4750. So what does that mean? That means that on my histogram, if I had somebody with 4,750 Twitter followers, they would appear somewhere along 3.6767 on the scale. So they would be appearing somewhere along here. Now, just as an extension of a couple of ideas, you may be asked to update the histogram to add a new person who has 10,000 Twitter followers. So what you need to do here is basically find the log of 10,000 to see which one of these columns 10,000 would appear in. So what you would do on your calculator, I'll just write it here, you would perform the log to the base 10 of 10,000. So that operation there, and if you did that, you would find that the answer would equal 4. So what you would do is you'd find column 4, and that needs to increase by another unit. So now we would have 2 people here. So you'll draw something along this, and a little bit untidy, but you get the general idea of what's happening there. Okay, I'll clear that annotation and move on to the next situation. Now, just reading this, a mistake was made reading the original data. Now, instead of 23 million Twitter followers a person X has, they only have 100,000 followers. Sorry about the English there. Make the necessary changes to the graph. So what we need to do is, well, we know straight up, because we've been talking about that for some time, that is our 23 million person with our 23 million Twitter followers. So you might say, well, how can I be sure about that? Well, if you wanted to be sure, you could, on your calculator, log to the base 10 of 23 million. And you'll notice that would equal 7 point a little bit there. Now, so that would need to go, and we know that that particular person has 100,000 followers. So what I need to do now is find out what the log to the base 10 of 100,000 would be, and that equals 5. So what it means is I would have a column here at the 5 of a height 1, which would make that alteration. So in other words, that column has moved over to there. So there you have it. I hope this presentation has given you a bit of an introduction of working with logarithms within the confines of a histogram. So until next time, good maths and